Hello viewers, I am Dr. Mala Das Sharma. Welcome you to my channel Chemphilic. Let's start 41 episode of Teaching Chemistry through Riddle. Here is our riddle number 41 which goes like this. Here is Mr. X, a VIP. You have to pay a handsome amount if you want to bring him to your lab. He is an escapist, can convert himself easily to different species and escapes away. People use him in a well-known volumetric analysis method that can be applied to estimate cupric ion. If you draw anything with a colorless divalent lead solution, he can make your invisible painting visible which appears as golden yellow. Now the primary question is, who is Mr. X? The answer is potassium iodide. Second question, in which form Mr. X escapes away? Any oxidizing agent oxidizes the potassium iodide easily to iodine. So, iodide is easily oxidized to iodine and released. Second question, what is the well-known volumetric analysis method referred in the riddle and what is the principle behind it? The well-known volumetric analysis method is iodometry. In acid solution, all oxidizing agent oxidized iodide to iodine quantitatively. And then the iodine formed by the reaction between the oxidizing agent and the iodide is titrated with standard sodium thiosulfate solution. This indirect method of titration is known as the iodometry. An iodometric method can be used in the quantitative determination of strong oxidizing agents such as potassium dichromate, permanganate, hydrogen peroxide, cupric ion and oxygen. Now coming to the principle of iodometry. The reaction between the iodide and the oxidizing agent, that means this redox reaction is quantitative. That means the amount of iodine released by this reaction is the measure of the amount of the oxidizing agent present in the solution. And once again, the amount of sodium thiosulfate required to titrate this iodine is equivalent to the amount of this oxidizing agent. Say your oxidizing agent is dichromate ion, which oxidizes the iodide to iodine in acid medium. So, iodide is oxidized to iodine and the dichromate is reduced to chromium plus 3 state. And then this released iodine is titrated with sodium thiosulfate, whereby sodium iodide and sodium tetrathionate is formed. Now the question is, this is one of the Viva question, that this iodine is very less soluble in water. Then how this sodium thiosulfate reacts with this released iodine in the aqueous medium? Actually what happened, the released iodine forms a triiodide ion with the iodide. So forms triiodide with the iodide present in the solution, which is fairly soluble in water. So the equilibrium present in the solution, that is iodine plus iodide, it gives the triiodide. Next question, Viva question, that is starch indicator is used for this titration of this iodine with sodium thiosulfate. Why? Because when you are heating or boiling the starch, a number of decomposition products are formed. Then out of those products, one is beta amylose. And this beta amylose component, it forms this deep blue color with iodine. That means it forms a complex with iodine whose color is deep blue. Now the fourth question, explain the method of estimation of oxidizing agents, a cupric ion, by iodometry. Now there are two steps. First step is standardization of sodium thiosulfate by known strength of the oxidizing agent. So what you have to do? You have to take known amount of known concentration of oxidizing agent. Then in acid medium, you have to add excess potassium iodide solution and you have to keep it for some time. Iodine will be released and the solution will become deep red color. Then this solution you have to titrate with the sodium thiosulfate solution whose strength you want to determine. And already I told you the oxidizing agents such as potassium dichromate, bromate, iodide and cupric ion can be employed in this procedure. And the reaction proceeds quantitatively in neutral or slightly acidic medium. Now coming to the experimental procedure. So as I told you, you add oxidizing agent and excess iodide in acid medium, keep it for some time, then iodine will be released and then the color will become deep red. Now, you titrate with the sodium thiosulfate solution, that deep red color will gradually go and you will get the yellow color and that yellow color will fade slowly and finally it will become very light yellow color and then at this stage you have to add this starch indicator, then immediately the solution will become deep blue. Then you continue the titration till the deep blue color goes away. That means the end point is deep blue to colorless. In case of dichromate, you will get light green color solution at the end point due to formation of chromium plus 3 ion. Then the question is why we are not adding iodine at the why you are not adding starch solution on the indicator at the beginning of the titration. So this is one of the Viva question. Why starch indicator should not be added at the starting point in case of iodometric titration. Actually, you have seen that endpoint is the blue-violet color to colorless. Now, in presence of high concentration of iodine, this disappearance of this blue-violet color is very, very gradual. So, if you add this indicator near the endpoint, then the endpoint will be sharp and sudden. So, if the starch indicator solution is added in the presence of high concentration of iodine, the disappearance of the blue-black color is very gradual. For use in indirect method, the indicator is therefore added at a point when virtually all of the iodine has been reduced to iodide ion, causing the disappearance of the color to be more rapid and sudden. Now step 2, that is your actual step or estimation of cupric ion by iodometry. The basic reaction in the determination of copper using iodometric method is this one, where the cupric ion oxidizes this potassium iodide to iodine and itself reduced to cuprous ion, and that cuprous ion present in the form of cuprous iodide precipitate. That means the cuprous ion is precipitated out as cuprous iodide precipitate. And this reaction is rapid and quantitative under 3 conditions. Number 1, solution should be slightly acidic. There should be large excess of iodide ion present and the copper should be present in the simple form, not in the complex form. And moreover, it is quantitative because of another reason. This reduced form of the cupric ion, that is the Q plus ion, it is present in the form of Q plus iodide solid. That means the reduced form or Q plus ion is precipitated out or removed from the solution. That's why this reaction is more quantitative. Now coming to the experimental procedure. So you should add this cupric ion solution, acid medium, excess potassium iodide. Keep it for some time. Iodine will be released. The solution will be here. The solution will appear as deep yellow color. Now you run down the standard hypo solution till this deep yellow color fades. At this point, you add a starch solution. When you add starch solution, it will become deep grey color. Here it will not be deep blue color because that precipitate is there. No, so it will appear as deep grey color or bluish grey color. And you continue the titration till this blue color is faint. And you will get this color. Now, at this stage, you have to add either potassium thiocyanate or ammonium thiocyanate solid. Why? This is another important Viva question. Because some of this iodine get adsorbed at the surface of the Q plus iodide solid. To remove or to make free those adsorbed iodine from the surface of the solid Q plus iodide, you have to add this ammonium thiocyanate or potassium thiocyanate. So, this is another Viva question. Why you have to add this potassium thiocyanate or ammonium thiocyanate? Then, when you are adding this one and dissolving that solid substance, then what will happen? Adsorbed iodine will be free, and once again the color will become blue-grey color or bluish-grey color. Okay. Now you continue the titration till the blue color disappear. That is the end point. Now the fifth question. What is the composition of the golden yellow colored visible paint? Now this lead solution, which is colorless, that forms a golden yellow colored precipitate with iodide ion. That means in the lead solution, if you add potassium iodide, you will get the lead iodide precipitate, which appears as golden yellow precipitate like this color. Lead solution, if you add potassium iodide, this colored precipitate will be formed. Now, this reaction you can use it as a magic in your lab. See, you draw something on a paper with the colorless divalent lead solution and then dry it. Then that paper you dip it in the potassium iodide solution. So what will happen? Golden yellow colored lead iodide precipitate will be formed. So your invisible painting will appear as golden yellow colored painting, or it will become visible. So this is the end of the video. Thank you.